Okay. So we're gonna go to the page that we left off on. We finished the first page of examples where we started to graph, and then on the second page though, I want to skip the one that says number 9 because that one the base is 1/2, and you already saw that, and then I know what's gonna happen is you guys are gonna think that every base should be 1/2, and I don't want to establish that. So if we have time at the end, we'll come back to it. But let's just skip to number 10. So number 10, they want you to determine the characteristics for the graph, right? So let's take a look at this. If you learned anything yesterday, what does this appear to be? Before we start getting into anything specific, what does this appear to be? How many different types of exponential functions are there? There's two, right? Do any of the two look exactly like this? Do any of the two look like this? No. So, I mean, we don't know for sure yet, but more than likely, okay, if none of the two that we learned look like this, that means that this has undergone some type of transformation, okay? But more than likely, which type of a function is this? And more than likely, what type of transformation has it undergone? This does look like it would be a decay, but a decay that would have done what? Oh yeah, reflection. And the way you can tell, remember, a growth um, looks like this. Oops, that's not gonna work. The growth, as you go right, it goes up, right? So if you were to flip it, if you were to flip that over the x-axis, it would look like that, which it obviously doesn't. Whereas a decay, as you go to the right, what do we call that invisible line that the graph approaches but never touches? An asymptote. Asymptote. That P is fun to say. Asymptote. So a decay looks like that. And if you were to get a decay and flip it over the x-axis, that's the one that can look potentially, if you look at the arrows, the end behavior is doing the same thing here. But let's see, let's investigate it further. Let's see if we can answer the questions. So this one we don't have to graph, let's graph forward to see if you can answer the questions. Domain. Okay, you learned last semester, what does domain mean? The what? What are all the possible x's you see? Or you can say how far left and how far right does your graph go? Looking at this picture, what does the domain appear to be? Yep. As far as just with respect to left and right, even though this looks like it's going straight down, it is not. If you give this enough space, it will go forever to the left. It will go forever to the right. If you were with me and many other different resources that we use, sorry, my voice is, my throat is almost swollen shut today, so just bear with me. Okay, this is the only lecture I have to give today. They call it all real numbers. Okay, you might see it referred to as all real numbers, but more than likely, I know like other teachers, they use interval notation a lot, so you've probably seen it like this. My kids have also. From negative infinity to positive infinity with parentheses. This tells you that these arrows will go forever to the left and forever to the right. Okay, how about range? Range means how far up and how far down. What would you say the range is here? Yeah, see, this graph, the left arrow looks like it's going down forever. So we will actually go down forever, but you see how as you go up, it starts to level off. And the reason why it's leveling off is because of that horizontal asymptote. Where does that horizontal asymptote appear to be? Huh? At 1, yes, at 1, because it looks like the boxes are worth 1. So there's two ways you can write this. And you don't need to write it both ways. I'm just showing you more than one way of writing it. How could you express all the numbers that are less than 1? Well, you could say y is less than 1. Wait, but Mr. Romero, in the past with parabolas, you wouldn't write less than, you would write less than or equal to. How come this is less than and not less than or equal to? Because you can't actually touch 1. There's an asymptote covering 1. You can't actually ever reach 1. So you have to stay below 1. Or you can also write this as negative infinity to 1. But now the 1, instead of the 1 having a bracket, it would carry a parentheses also, because you're not allowed to touch the 1. Okay, y-intercept. If you're confused on anything I'm saying, raise your hand. Now you're never gonna learn this. I'm hoping it would be easier if you already at least understand the concept of domain and range. Now we're just applying it to a different function. How about y-intercept? Where it's touching the y-axis? It appears to be at 0, -3. I agree. Hey, look at that. We learned about horizontal asymptotes yesterday. Where is this horizontal asymptote? Somebody not named Ann. Tell me. No, Ann already said it. Where is this horizontal asymptote at? Sam? Where is the horizontal asymptote at? Can't see it. It's invisible. Like yesterday, I was drawing it for you, but it's mostly I'll draw it for you there. A horizontal asymptote is an invisible line that your graph gets close to but never touches. It has an effect on the range. That's why the range was limited. So how can I describe that imaginary line that I just drew? Marmy, any idea? Kiara? Well, at least that's part of it, but that's not the entire thing. And you want to help out? Yeah, you should have already learned way back when we were doing linear equations that any horizontal line starts off with y equals. Subsequently, you should have also learned that any vertical line. When recently, if you remember, when recently have we been worrying about or focusing on? That's a better word. Focusing on the equation of a vertical line. The axis of symmetry, very good. When we did axis of symmetry, we talked about the equation of vertical lines. Well, this is horizontal. Vertical lines start with x equals. Horizontal lines start with y equals. So y equals what? Well, where is that imaginary line crossing? The y-axis at 1. Okay, now this next part is function evaluation. They want us to evaluate this function at 1. This is a way of saying that the 1 is the x or the y. The x, good. So when x is 1, it's hard to tell for sure, but we'll do the best we can. It appears that y is what? -1. I agree. If you're not sure, let me know, but it appears point right there. That's at 1, -1. Now this next part where they say f at what gives me -15. Now they're saying that the function is -15. It's a way of saying the y. They want you to know what x goes with it. So if we look up on the y, -15, it appears that the x is what? I would also say -2. You really never can know for sure. You're limited by the precision of the graph, but yeah, it looks to be -2. I'm not. I'm guessing. I get it because it doesn't really explain here. But I'm guessing what they mean by increasing or decreasing is they want to know intervals. They want to know like under what intervals is this function increasing and when is it decreasing. You should have learned before that when you use these words increase and decreasing, what you assume is that you're looking at the graph from left to right. When I've explained it before, I've explained it like a roller coaster. Like here's Lulu Makai on the roller coaster and he's excited. And the roller coaster always goes from left to right. Okay, so as you go from left to right, what is the graph also doing? As you're going from left to right, what are you also doing? So you're also going up. Now, see if you remember with a parabola, like a parabola could start going up, but eventually once you hit the vertex, it started going down. There were intervals when we talk about like some up here when we did domain, those are intervals. When we did range, that's an interval. Now, when you talk about increasing or decreasing, you're talking about with regards to the domain. Under which section of the domain is it going up or when is it going down? Parabolas always have a going up part and a going down part. Even if it was a regular upward facing parabola, the difference would be you're going down first and then you're going up. So always from left to right. Exponential functions do not have a change of direction. Other than that, it doesn't have a vertex. Either you're going to be going up always or you're going to be going down always. Okay, so now, even though, as in this case, as you're going up the roller coaster, it starts to flatten off and get like really, really, really boring, you're always still going to be going up. You're just going to infinitely be going up. You just never reach that one. You're never going to get there. But you're always going up. So really, the easiest way I can describe this, assuming that they're asking what I'm assuming that they're asking, is just copy the domain. Since it doesn't change direction, it's either going to be increasing or decreasing over the entire domain. Now, again, in this particular case, which one is it? Is it increasing or decreasing? As we go from left to right, are we going up or down? We're going up. So this is going to be increasing from negative infinity to positive infinity as well. And this is never decreasing. Okay. Maximum and minimum. When have you heard those words before? Maximum and minimum. With a vertex. Okay. Now, an exponential function does not have a vertex. But with regards to the vertex, like a parabola was either going down and then up or up and then down. Which variable goes up and down? Which of the variables is in the up and down direction? Why? So when you say maximum or minimum, a parabola just happened to have a maximum and minimum at the vertex, but maximum and minimum does not always mean vertex. It just means how high does the function go and how low does it go. The minimum we know. Well, I guess if you even want to call it that, I mean, it's not really a number that exists, but like how low will this go? To negative infinity. How high will this go? Yeah, but it never really touches one. So I don't even know how you would write that. It doesn't really have a maximum. It's just gonna go forever and never touch one. Um, I guess I would put y less than one or something, but I'll double check. We have a quiz on Tuesday, but the next time I see somebody in the math department, I doubt that's going to be on the test. I'll ask. Now, definitely what I think will be there, and this we did talk about, is end behavior. This is arrow notation. So let's see, when I say x is going to negative infinity, what direction does that imply? When x is going to negative infinity, what direction are we going? Left. So So this is a way of saying what is the left arrow doing that we already talked about. In addition to going left, what else is that left arrow doing? Going down forever. So then you would put f of x is going towards negative infinity. As x goes to negative infinity, y goes to negative infinity. Ooh, let's see who remembers what word is used for the arrow. What word does the arrow imply? Even put up in the board in Vietnamese. I remember. Approaches. So as x approaches infinity, what direction are you going if x is going to infinity? No. As x is going to infinity, what direction are we going? To the right. So this is just a way of saying, okay, the right arrow, comma, is doing what? Well, then yes, as what you said, it's going to k. K is a horizontal asymptote. That's at 1. Now, what you may or may not see, there's a little superscript. It's called a superscript. An exponent is a type of superscript. It's like a little number that you anchor towards the top. When you use arrow notation a lot and you're headed towards a number, not if you're headed towards infinity, but if you're headed towards an actual number, you might see a little sign. Not in front, not like saying, oh, -1. I'm not talking about in front. I'm talking about a little symbol that gets put up here on the top. And what that is saying is, all right, yeah, we're going towards 1, but are we approaching it from the bottom or are we approaching it from the top? Yeah, you're coming at it from the bottom, right? So you might see it also with a little minus up here. That's just saying that you're approaching 1 from the bottom. If this would have been like a regular decay and doing this, and you would have been approaching it from the top, if you put like a little plus there. I doubt you're going to have to do that, but hey, it's just free information, yeah.
Maximum, like 0.9.
No, because it doesn't. There's no such thing. If I were to ask you, hey, how many numbers are there between 0? I would ask you, how many numbers are there between 0.99999999999999999, so on and so forth, all the way to 1. How many numbers are there between that and 1? An infinite amount. Because I can keep on writing 9s until the day I die. There's an infinite amount. So that's the thing, that there is no actual number that's just below 1. So I wouldn't even, I'm being honest with you, I wouldn't even know how to write that out. I'd be curious, but that's why I don't know. I think they put this stuff here. I didn't make these notes. These are the department notes. But I know the minimum is negative infinity. But the maximum is whatever the number is, it's below 1. I have a feeling they would put 1, but you can't call 1 the maximum because it never reaches 1. So let's go to the next page. Okay, now we're back to graphing. Graph all of these functions and identify the domain, the range, the x-intercept, the y-intercept, and the horizontal asymptote. Okay. I'm going to graph it, and we can do the domain and range stuff verbally, and the x and y-intercept verbally. Okay. First thing, let's identify the parent function. What is the parent function for the first graph? When I say parent function, I mean what is just the base with the exponent? Okay, what's the base of number 1? 2. Okay, I was not here. What is the base? The base is just the number directly before, or directly underneath. So what we did yesterday is we need a set of starting values. You pick the x's that you want, and then we figure out what the y's are that go with it. Because the base is 2, what type of a function is this originally? It's a growth. And with growth, now because you have to, we just finished saying, what's the domain of any exponential function? What's the domain? If domain is the x's that you're allowed to pick, the x's that it contains, how many x's are there on an exponential function? An infinite, yeah, there's an infinite amount. So you're just gonna pick some of them, but which ones that I recommend for you to pick on a growth? 0 and positives. So I think if you get at least 3 of them, that's fine. Since I don't see any stretches here, I'm going to be crazy and I'm going to pick 4 different inputs. And then I'm going to take turns. I think I didn't write a y yesterday, even though that's what we were looking for. I think I wrote it as 2 to the x. So you know how I was getting the y's? Same thing. What is 2 to the 0 power? 1. What is 2 to the first power? 2. What is 2 squared? What is 2 to the third? 8. Yeah. You don't determine anything, because what I just finished showing you is that what I mean by determine, you're not forced. Technically, you can use whatever you want, because the domain of an exponential function is all real numbers. It goes forever to negative infinity, forever to positive. You can pick whatever x's you want. It was more of a recommendation. If you want the graph to go by smoother and easier, if you want the points to be a little bit easier to plot, and even then I can't guarantee you, because it depends on exactly what the base is. But if you want to make your life a little bit easier for gross, which are the ones where the base is greater than 1, like it is here, pick 0 and positives. For decays, pick 0 and negatives. The next one we're going to do is a decay. The base is 1/3. I'm going to pick 0 and negatives. But not because I have to, it's because I want to. Okay, now let's identify the transformations. What's A here? -1. Sam, what's H? Good, what's K? So to try to make this process more efficient, can you tell what's the only transformation that's going to have an effect on the appearance of the graph? A. Yeah, A is the only one that's going to do anything. So I gave you a formula that said x plus h, y times a plus k. But anytime h or k are 0, you can ignore them. Anytime a is positive 1, you can ignore it. So I almost got away with just ignoring everything, but I do have to pay attention to the fact that a is negative.
On the graph, not on the graph, on the table.
This one here?
Yeah.
Take 2 to the 0 power. Hey, no, it's 1. Where's your calculator? That's why I love 0. 0 to any number to the 0 power is 1. You didn't get the Hawks calculator at the Hawks store? Let's go. So when I use this formula, I'm only gonna do the y times a part. So the first x I have is 0. The first y I have is 1, but times -1, that gives me 0, -1. The first, Brian, it's easier to see if you have your eyes out. The second x I have is 1. The second y I have is 2, but that needs to get multiplied times a. So 1 and -2. Marmy, what's the next x I have? I'm just going down the line. What's the next x I have? 2. I already did the 1, so now it's 2. I'm supposed to add h to it, but anything plus 0 is itself, so I can ignore that. And then 4 times -1 is 2 -4. The last one I have is a 3, comma 8 times -1 is 3 -8. So these are the points I want to graph. Also, to help guide me, Nakai, I want to draw my asymptote. Where is my asymptote going to be at? For the second time today, where's the asymptote going to be at? Remember, starts out with y equals, and it's not going to be y equals -1, because we said yesterday it's going to be at k, and what's k? K is 0, so I'm going to draw my asymptote. So there's the asymptote. Put the points 0, -1, 1, -2, 2, -4, and then 3, -8. And then if I connect these points and use the asymptote as a guide, something like that. Notice how this looks like a growth that was flipped over the x-axis. You can write down on. I gave you the notes. It's yours to keep. And these are all things you could be writing down and plotting.
I'm like on the black, which one? Trying to see stuff. Why don't we, like, why do you have to go through all that work?
Yeah. I mean, here you got lucky. There's only one transformation. Look at the next one. There's going to be 2 transformations there. How about if you have 3 transformations? How about if you have 4 transformations? You know, things can get a little bit Yeah, in this case, the only transformation was that a was -1, so whatever. I mean, yes, multiplying by -1 is, just changes the sign. But if I just think of it this way, remember where I'm coming from. If I just tell you guys, hey, look, guys, these are the points I'm going to graph. What do you think people are going to say? What? Like, how'd you get that? I don't get it. Where'd you get those from? So I'm just showing you how I got them from. I got all of these y's, and I multiplied them by a because that's what you were told to do. But wait, Mr. Romero, why didn't you add h and k? Because you also said to do that. Well, I did, but what were h and k here? 0. What's anything plus 0? The number itself. Here, let's do the next one. I need to come up with a group of starting points. Marquise, you can pick whatever points you want, but I think you like things easier than harder. So, and even I can't promise you that this is always going to be easy, but yes. Oh, that's true. Sorry about that. Thank you. Oh, there is a space to write this. Okay, I didn't think that there was a space to write this. So I thought you were going to do it verbally, but perfect. Even better. There's a space to write this. What's the domain here? Yeah, that's all it's going to be. All our numbers. We'll just use interval notation. Negative infinity to positive infinity. What's the range? Yeah, you can either write negative infinity to 0, but make sure the 0 has a parentheses. That is important. If you put a bracket next to 0, it's wrong. Or you can just write y is less than 0. As long as y is 0 less than 0. Where is this touching the y-axis? It was one of the points that we plotted up here. At 0, -1. I know my drawing isn't the best, but it's not easy to draw with these things. Again, where was our horizontal asymptote? Huh? Yeah, y equals 0. As far as increasing or decreasing goes, it's only going to either increase or decrease. There is no change of direction on exponential functions. Is this one increasing or decreasing? As we go, in this roller coaster, we're going from left to right. Would you be going down the roller coaster or up? Down. So this is decreasing under all parts of the domain. So it's the same domain, it's just always going to be decreasing. Let's leave out maximum and minimum, because I don't even know what they're at. I can tell you, like, it looks like the minimum is negative infinity, and the maximum is 0, but you never really reach 0. So, I don't know. I don't want to say something wrong and confuse you. I don't know what the person that wrote this was intending to ask you for by putting those 2 in there. Maybe that was supposed to help you get to end behavior. That's the only thing I could think of. Because really, this maximum and minimum leads to end behavior. X is going to negative infinity. That means the left arrow. What is the left arrow doing? It's going to K, which is, I guess that's what you would have thought the maximum would have been. It's going to K. What was K here? 0. So more than likely, you would just see a 0 there. But just in case, sometimes they put a little superscript. Are you going towards k from the bottom or from the top? From the bottom. So you might see like a little zero with a minus there. Sometimes they write that. I'm not gonna ask you to like on the test or quiz. I'm not gonna mark you wrong if you do the little thing off. But you do have to know it's going towards zero. What is the right arrow doing? Where is it headed towards? What is it approaching? Negative infinity. That's the only thing I can think of is that for like, why would they put maximum and minimum is because that's what leads you to know that behavior. But even then, that's not the words I would use. I don't really like the use of those words. All right, let's do the next one now. What type of a exponential function is number 2? That's a decay. How do you know it's decay? The base is between 0 and 1. So let's come up with a set of starting points. Here, maybe to help you here. This one, let's just put x and y. Maybe that'll make more sense to you. Marquise, where do I get the x's from? The correct answer to that is wherever I want, wherever you want. Where do you get the x's from? You pick them. Okay, but then an addendum to that is you could say, yes, but Mr. Romero, you said what you wanted, what you preferred is on growths to use 0 and positives, for decays to use 0 and negatives. But I just want to make that clear. It isn't because you have to, it's just a smarter way to go. So I'm going to use a 0, a negative 1, a negative 2. I'll stop there. I can tell negative 3 is not going to fit. So let's just do 3 points here. Do it if you want. Just I can tell the y is going to be too big to fit on that window. When we do this, we are only taking the base to that power. So Caleb, show me you learned something. What is 1/3 to the 0 power? It's 1. Any number to the 0 power is 1. Now, if you paid attention yesterday, and I guess the day before, what happens when you take a number to a negative power? This is the whole reason why we're using negative powers. The base flips. So taking 1/3 to the negative 1 power is the same thing as taking 3, because that's the reciprocal of 1/3, to the positive 1 power. So if that's the case, what is 1/3 to the negative 1 power? It's 3. What's 1/3 to the negative 2 power? 9. Now I have some points to work with. So let's do the same thing we did last time. Let's identify A, H, and K. What's A here? Again, negative 1. What's H? 0. What's K? So what transformations are going to have an effect here? A and K, yes. A and K are going to have an effect. So what of the two coordinates does A and K directly affect? If you look at the formula I gave you on the top, what do A and K both affect? Just the Y. So what's going to happen to the X's on this table? Nothing. So I can start off with 0, Marvin. And then the Y that goes with 0 is 1, but that has to be multiplied by negative 1 first, and then add 3. That's what the formula says to do. 1 times negative 1 is negative 1 plus 3 is 2. So 0, 2 is going to be on my graph. The next point starts off with a negative 1 on the x. The y is 3, but that 3 has to be times negative 1, and then plus 3. What is 3 times negative 1 is negative 3 plus 3 is 0. Good. Negative 1, 0. I'm going to go on my graph. Then finally, negative 2 goes with 9. So negative 2 stays the same, comma, 9 times negative. What is 9 times negative 1 plus 3? It is negative 6. 9 times negative 1 plus 3 is 6. And, no, sorry, negative 6. That looks like it's barely going to fit in my graph. Where is my horizontal asymptote going to be? At K, and K was 3, very good. And please, let's start being specific. Let's not just say 3, let's say y equals 3. So that's here along the top. I draw a horizontal line. And I gotta make sure I don't touch that. If the points I start plotting are above it, I better not go below that line. If the points I start plotting are below it, I better not go above that line. You gotta stay entirely in that area. So 0, comma, positive 2 is up here. Negative 1, comma 0 is here. And then negative 2, comma 6 is down here. And if I use my knowledge of exponential functions along with the asymptote, I can sketch. It's never gonna be perfect, but I can sketch it to look. I feel somewhat relieved because I feel like some of you are starting to understand this, but I'm also somewhat worried because I don't think it's enough. I think it's maybe 2 or 3 of you that are starting to get this, and the rest of you are just crickets. So if you don't understand something, say something. Somebody not named Anne or Marquise, tell me what's the domain going to be here, or Nakai for that matter. I don't know Nakai knows this too. So anybody that's not one of those 3, tell me what's the domain going to be here. Yeah, because these are going to go forever left and right. If you learned anything from the last 2 examples, where are we going to see that negative infinity to positive infinity again? Like, where does the domain repeat itself? Huh? Where have we basically been just writing that domain over again? Nah, not necessarily on behavior. And? Yeah, where it says increasing or decreasing. Because when you're talking about increasing or decreasing, they want to know along the x-axis, when is it going up and when is it going down? But since these don't change direction, they're always either going up always or going down. Is this one going to go up always or go down? Excuse you? Yeah, because remember, when you say increasing or decreasing, you're going from left to right. This was a roller coaster, and the guy was on it, he'd always be going up. He'd flatten it out a little bit, but he'd always be going up. So I can just go ahead. I'm just trying to change up the order that I write this to see if maybe something clicks for you. This is never going to be decreasing the same way the first one was never increasing. We'll leave out the maximum minimum stuff because I think I'm more likely to confuse you than anything there. You know, the only thing I can think of them even asking you that for is to try to help you understand end behavior, but I'm hoping you understand end behavior anyways. What's the range? Where are all the y's here? Up until? Yeah, 3 good. So we go negative infinity up to 3. Make sure you put a parentheses. If you put a bracket, it's wrong because you never reach 3. And I'm fine with either one. Maybe your last teacher, if you weren't with me, only accepted interval notation. But if you put with me y is less than 3 because that helps you understand it, I'm fine with it. Huh? Well, because the range means how high and how low. So how low does this graph go? Well, this arrow tells me here that the graph goes down forever. How high does it go? It goes as high as 3, but it's never going to touch 3 because of that asymptote. It's like a force field. It doesn't, you're not allowed to cross it. Huh? you know that there's numbers in between 3 and 2, right? All sorts of fractions and decimals. So you're gonna infinitely, it's gonna be like you're going through some type of portal and you're like, oh, hyper speed, and I need to get there, I need to reach 3, and you keep on trying to reach for it, but you never actually get to 3. Where's the y-intercept here? Where am I touching the y-axis? 0, 2. And then where's the horizontal asymptote at? At where? At y equals 3. Get in the habit of putting that. If you do not put the y equals on it, at best you're going to get partial credit. Kiara, since we were just talking about end behavior, I'll let you do the end behavior part. As x goes to negative infinity, which is just a way of saying, like, think of it like reading another language. Like when I put Vietnamese up on the board yesterday. But now you're reading the arrow language. So this arrow language is just telling you, when x goes left, what is y doing? What is the left arrow doing? There's 2 arrows. Here's one arrow. Here's the other arrow. So besides going left, what is this left arrow also doing? Going down. So how would I write that? I would write that as negative infinity. Going down to negative infinity. The next part says, as x goes to positive infinity, as I go to the right, besides going to the right, where is this other x also going? It is going up, but it's not going up forever. Like, where is it? What is it? These are also called limits. When you get into higher levels of algebra, you'll hear these called limits. What is the limit on how high y could go? To 3. You probably don't need to know this, but just in case, you can go home and tell your parents you learned something new. Is this going towards 3 from the bottom, or is it going towards the 3 from the top? From the bottom. It's underneath the 3. So you might see with a little minus up here on the top. That's just telling you that you're approaching, your airplane is going towards 3 from the bottom. QN, is that confusion? You're confused? What are you confused about? And I'm confused unless you tell me. Ask her, is it more of a language thing or a math thing that she's confused about? Okay. It's hard to fix. Here, I just got my 10-minute warning, so let's try to do a few more and maybe it'll help her understand it. There's just 2 more here. Okay, I think we can knock these out. Let's do these quickly. The next one, number 3, is it a growth or a decay? This is a growth. What's the base? 5. So the way I come up with the y's is I'm going to take 5 to the power of the x's that I pick. Marquise, what would be a smart set of x's to pick for this? Well, 0 and positives. How far positive you get depends on how much space you give yourself. I wouldn't go all the way up to 3 because 5 to the 3rd power is 125. I don't think that's going to fit here. So let's just do 0, 1, and 2. If you can get 3 points, I'm happy with it. 2 points is like, that's not enough. 3 is fine. 4 is better, but 3 is fine. Qyen, what is 5 to the 0 power? 1. Anything to the 0 power is 1. What is 5 to the 1st power? 5. What is 5 squared? 25. Okay, so these are starting points, parent points. We're going to use this to start off, but these are the points that are going to go through the portal and get transformed. We're going to transform them by using A, H, and K. What's the A here? What's A? Who's saying that? Kiara. When you talk to Taiwan, do you talk that low? You yell at him? I think it's impossible. I can't imagine Kiara yelling. I'm gonna ask Taiwan about that tomorrow. H. What's H here? And what's K? 5. So let's transform these points quickly. I'll just do them here because I'm running out of space. Which transformations are going to have an effect here? Just A and K. So all the x's can stay the same. I can keep the 0, but then 1 times -1 plus 5, which that gives me 4. 0, comma 4 is going to be a point. Okay. Then 1, comma 5 times -1, which is -5 plus 5 is 0. 1, comma 0 is going to be a point. 2, comma 25 times -1, but then plus 5 is negative. It's going to be -20. So 2, comma -20. I guess they've conveniently made the graphic for you. I guess that's what they intended for you to graph is 3 points. So now let's graph these. So that I don't forget, I like to do the asymptote first. Sam, where's this asymptote going to be at? Y equals 5. Y equals 5, which is right on the top. Now we can plot our points. 0, 4, 1, 0, and 2, -20. It's a little harder for me to draw, but it should look something like that. It's just a sketch, something like that. Yu Yang, what is the domain going to be? How far left and how far right will this go? Negative infinity to positive infinity. The answer is the same every time for domain. Kiara, this gave you a little bit of trouble last time, so how about range? What's the range going to be for this one? From where? The easier way to probably say it is y is less than 5 because this graph is entirely under 5. Or in arrow notation, you would say negative infinity 5. You don't have to do it both ways, just do one or the other. What's the y-intercept here? Where am I touching the y-axis? That's 0, 4. Where's the horizontal asymptote? At y equals 5. Is this increasing or decreasing? Decreasing. Where is it decreasing? Everywhere. It's always going to be decreasing. Well, don't worry about maximum and minimum. I really got to ask why they even put this there. But let's do end behavior. First, x negative infinity, that's left. What's the left arrow doing? No, the left arrow? It's going up, but it's going towards k. K was 5. Is it approaching 5 from the positive, from the top, or from the bottom? It's underneath it, so you can click a little negative there. And then what's the right arrow doing? Going down to negative infinity. Let's do the last one real quick and we'll get as far as we can get. Is that a growth or decay? That is a decay. So I'm going to pick 0 to negatives. Judging by, it looks like they probably just want me to do, well, what inputs did I tell you that you're better off with the decays? 0 and negative. So I'm just going to go 0, -1, -2. Because -3 is already going to be 64. That's going to be kind of big. What's anything to the 0 power? 1. What's 1/4 to the -1? 4. Good. What's 1/4 to the -2? That doesn't matter. That doesn't matter. What's 1/4 to the -2? 16. And where that does matter is when you identify A, H, and K. A is -1 here. It's another flip. H is -2. K is 0. So what points are what transformations are gonna affect this? A and H. So H now for the first time has to get added to the x's. So I would have 0 minus 2. I'm going to have 0 minus 2. And then all that happens to the y's is change the sign 1 times negative 1. So it's negative 2, negative 1. Okay, then I'm going to have negative 1, also minus 2, and then 4 times negative 1. So that's negative 3, negative 4. Okay, then negative 2 minus 3, and then 16 times negative 1. So that's negative 5, negative 16. The asymptote is going to be where? Where's the asymptote going to be at? At 0. Kind of cheated to put that on top there for you. And then when I plot the points, negative 2, negative 1, negative 3, negative 4, and negative 5, negative 16. This one I actually don't know where the y-intercept is going to be. You have to use like a graphing calculator for that, or you can solve it algebraically. If I were to ask you what transformations that underwent, what would you say? What are the actual, like in words, what transformations occurred there? X-axis reflection and you can just flip that, yeah, translation.